Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So students, we are already done with the organic chapter and today we are going to solve the top 40 PYQs from this chapter, including both KCET and COMEDK questions. Okay, so please join our WhatsApp channel to get access to all class notes, PDFs and everything. So let's get started here with the first question. Okay. Fine. IUPAC name, you can see very simple structure, name it 1, 2, 3, 4 and on second and third we have the substituents. So the name will be obviously 2,3-dimethyl but 2-ene, option number A. Alright. Next, again you have to tell the IUPAC name. Again I can number it from this side 1, 2, 3, 4. Okay. So 1 bromo and we have but 2-ene, right. So but 2-ene and 1 bromo, option number A. Next, IUPAC name of this compound, you have 1, 2, 3, 4 and 5, right. So 4-oxo and you have pentane 1-oic acid. Okay, so option number B here. Next, identify the correct IUPAC name of the compound. So you have 1, 2, 3, 4 and this is nitrile, so it is butane nitrile, option number B. Next, IUPAC name of tertiary butyl chloride. So if you draw tertiary butyl chloride, it is like this. Okay, tertiary structure you should be knowing, students. So you can see this is 1, 2, 3. So we have 2 chloro and 2 methyl propane, right, option number A. Next, malic and fumaric acid. So you should know these are all optical isomers. Okay, sorry, 1 second. Okay, so these are your geometrical isomers. Okay, they are geometrical isomers, otherwise they are cis and transform or else they are the same structure. Which of the following is not a functional isomer? It is not a functional isomer. So if you see here, okay, both are ether functional groups, so it is not a functional isomer, option number D. Next, identify the correct statement in the following. So dimethyl ether and ethanol are chain isomers. No, these are what? Functional isomers. Ethanoic acid and methyl methanoate are position isomers. No, these are functional isomers. N-butane and isobutane are functional isomers. No, these are chain isomers. Propane 1-OL and propane 2-OL are position isomers. Yes, this is correct. So option number D. Next, the structure of CH3, CH, NH2, CH2, CH2, CH3 and the two structures are given, represent what? So if I draw this one, it is CH3, CH, NH2, okay. Next we have CH2, CH2, CH3, okay, and you have one more, that is CH3, CH2, CH, NH2, okay, CH2, CH3, okay. So now this is what? You have 2 amino and this is 3 amino and this is 2 amino. 2 amino pentane and 3 amino pentane. So that is your position isomers, option number B. Next, 10th, which of the following is an isomer of ethanol? Okay, isomer of ethanol, if you see, the structure of ethanol is like this. So we need at least 2 carbons, right? So methanol has 1 carbon, we can eliminate. Acetone structure is like this. Okay, this is acetone. So how many carbons are there? 3 carbons. So this is also not correct. Diethyl ether. So diethyl ether structure is like this. So this is also having 4 carbons. This is also incorrect. Methyl ether it is, okay. Oh sorry, dimethyl ether, it is like this. Structure is like this. Right. So you can see 2 carbon, okay, and you have 1 oxygen and you have 6 hydrogen. So these 2 are isomers, option number D is the correct answer here. Next, the structure shows dash type of isomerism. Okay, you can see here this carbon here is not, this is the position, restricted rotation area, and you can see both the groups are same, so it will not show geometrical isomerism. But this carbon is chiral, right? You can see all the 4 groups are different. So all the 4 groups are different means it will show you optical isomerism. Next, methoxy, methane and ethanol exhibit. So if you have, just now we have drawn methoxy, methane and ethanol will exhibit functional isomers, right? This is your ether group and this is your alcohol group, okay. Next, which of the following compounds possess the CH bond which has the lowest bond dissociation energy? So if I see toluene, okay, the structure of toluene, okay, this is toluene. Now suppose this CH bond is broken, so what I'll get? I will get a carbocation here, and this carbocation is resonance stabilized, right? So now because of this resonance stabilized, what will happen? This bond can break easily because once the carbocation form, that is also stabilized. So that is why option number C is the correct answer here. Next, what is the hybridization state of benzyl carbonium? So if you see, this carbon structure is like this. If I just draw it, it is like C plus H2. So you can see it has 3 sigma bonds. 3 sigma bonds means the hybridization will be sp2, option number A. Next, the carbon atoms in ethene are. So if you see ethene structure, okay, so you have here ethene 3 sigma bond, here also 3 sigma bond. So this is also sp2 hybridized, this is also sp2 hybridized, okay, option number A. Next, the number of pi bonds and sigma bonds present in naphthalene are respectively. So if I draw the structure of naphthalene, it is like this we will get, okay. So now if I see, there are total 5 pi bonds, right? So 5 pi bonds, and sigma bond, if you see like this, I can draw the bond structures here, okay. Yeah, so now you can count, you will get 19, so option number B here, okay. Next, the number of sigma and pi in pent 2YENE. So let me first draw pent 2Y, right? So I will get here 3 hydrogens, here I don't have any hydrogen, here I have 2 hydrogens, and here I have 3 hydrogens, okay. So how many sigma bonds and pi bonds? So generally, definitely there are 2 pi bonds, so we can eliminate this option. Sigma bond 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 and 2, option number A. Next, what is the number of primary, secondary, tertiary and quaternary carbon atoms present in the structure? So if you see here, this carbon is, okay, let us see here. Yeah, now see, this carbon is connected to only 1 carbon, so this is primary. This carbon is connected to 2 carbons, so this is secondary. This carbon is connected to 4 carbons, so it is quaternary. This carbon is connected to 1 carbon, so this is primary. This carbon is connected to 1 carbon, so this is primary. This carbon is connected to 2 carbons, so it is secondary. This carbon is connected to 3 carbons, so it is tertiary. This is primary and this is primary, okay. So now you see how many primary are there? 1, 2, 3, 4, 5. So 5 primary is here. So option number, there is only one option with that, so option number B, okay. Next, the resonance effect is not absorbed in. So for resonance effect, what do we need? We need conjugation, right? We need conjugation for resonance effect. So can you see any resonance here like this? You can have resonance. Here also we have conjugation for resonance. Here also we can find resonance. But here you see there is no conjugation, right? Here there is N double bond, but after that there is no double bond here. So here we cannot find resonance. So option number D is the correct answer. Next, minus I effect is shown by, so minus I effect means your electron withdrawing group, so that is option number C, NO2. Next, group with electron withdrawing resonance effect is, electron withdrawing means minus R effect, nitro group, okay. Then again minus I effect is exhibited by CH3, these are all alkyl groups are having plus I, CN is having minus I effect. Next, in which of the following homolytic bond fission takes place? So homolytic will take place in free radical mechanism. So if you see, the first step here is the chlorine molecules in presence of H nu becomes Cl plus Cl. Right now we will get, okay, this one is there, this cleavage will take place and you will get like this, okay. So A. Next, CH3 whole 4N plus is neither an electrophile nor a nucleophile because, okay, so that is because you can see neither has an electron pair to available for donation, okay, because it is already forming 4 bonds, and neither it can accommodate electrons since all the cells of the nitrogens are fully filled. Okay, so option number B here. Next, the decreasing order of reactivity towards electrophilic substitution reaction of the following compounds. So now see, it has to react with electrophile, right? So that means what? This rings, these examples must be nucleophilic in nature, right? The one which is most nucleophilic will react faster. Now what are the groups present? Now see, this CH3 group, okay, is electron donating group. So it will increase the ring density, so it will react faster with electrophile. So 4 option will be there at the first, we can eliminate other 2. Why? Because NO2 is electron withdrawing group, chlorine is also electron withdrawing group, right? And this is neutral. So after this one will come, because here electron density is neutral. Here the electron density is in minus, here the electron density is in plus, right? So that is why after 4 we have 1, so both the options are having that. Now this 2 are pulling the electrons, okay? So chlorine pulls the electron by minus I effect, and NO2 pulls the electron with minus R effect, right? And we know that R is much stronger than I. That means what? NO2 will pull more, here it is more minus, so it will be very much less reactive towards electrophile, okay? Here it will be comparatively less, okay? So that is why what we will get means here there will be like less electron density, and here there will be comparatively more electron density. So we will get first 2, then 3, so option number C, okay? Next, carbocation as an intermediate is likely to be formed in the reaction. So in this case there is radical mechanism, here there is no carbocation formation, here also there is no carbocation formation, here there is formation of carbocation, so option number D. Next, which of the following is the correct order of stability of carbocations? Okay, incorrect order. Okay, so here you can see we have 3 phenyl groups attached. So if you can just see, you have like this. Okay, so these phenyl groups increase the electron density due to resonance, right? So that is why what I can say, if 3 phenyl groups are there, more stability will be there, then 2, then 1, so this order is correct. Now if you see here, you have C, CH3, CH3 plus and H, okay? Now this one will donate electron, this one will donate electron, but here, or you can see there are total 6 alpha hydrogen, but this is having 9 alpha hydrogen, so this carbocation is more stable, so this order is wrong, so our correct answer is option number B here. Next, the order of decreasing stability of the carboanions. So whenever carboanions decreasing stability, if you have more electron donating groups, then the stability will decrease, right? And here you can see all the 3 groups are more donating, so this one will be least stable, so you have only one option with that, so option number B here. Next, which type of intermediate A is formed during the reaction? So whenever you use heat or light, you will get free radicals, so option number C. Next, arrange the following in the increasing order of stability. Okay, so carbocation stability order you should find out. Okay, so here you can see there is no group attached, so definitely 5th is the least stable. Okay, so we have option number A and D. After you see 4, 3, 4, 3 is same. Now you have to compare between 1 and 2. So let us take the first one, that is C. You have 2 CH3 groups here. Okay, and you have a carbocation, you have CH2 group and you have CH3 group, okay? And the next one, that is your second one, is having like this, CH3, okay. Now out of these 2, which is more stable, you have to think. So that all depends on the hyperconjugation structures. Here you can see total 8 alpha hydrogens are there, and here you can find there are 9 alpha hydrogens. Okay, so these 9 alpha hydrogens will stabilize this carbocation, so it will be more stable. So definitely 2 will be more stable, so and 1 will be least stable, right? So I will get, after 3 I'll get 1, then 2 is the highest stable, so option number A. Okay. Next, homolytic fission of the following alkanes form free radicals. Okay. Increasing order of the stability of free radicals. Okay, so first of all you can see here there are 3, that is also you can tell on the basis of hyperconjugation. So here you have 9, here you have only Okay, we will see the number of hyperconjugation structures. Okay, so here you can see there are 9 alpha hydrogen, here there is 3, and here if you see 6 alpha hydrogen. So this should be more stable than this one. So here the order is wrong, so this answer is incorrect. Then you have the next one, here you can see 9 alpha hydrogen, so it is more stable. Then here you have like this is the radical, right? So here you have, let me see, CH3, okay, no, sorry, this is the radical present once again. Okay, the radical is this one, this carbon is having free radical. Okay, so here you have 6 and 8, so this is having 8 alpha hydrogen, so after 9 that is 8, that is also stable. Here you have 6 alpha hydrogen and here you have 3 alpha hydrogen, right? So based on the order, this has to be the correct answer. Okay. Next, which of the following statements is incorrect about partition chromatography? Okay, so in partition chromatography, mobile phase can be a gas. No, in partition chromatography, both the groups or both the components should be liquid. So option number A. Okay. Next, a miscible mixture of C6H6 plus CHCl3 can be separated by distillation because these both are liquids with a significant difference in their boiling point. Next, a miscible mixture of, so this question was repeated, you can see both in 2016 and 2019, so same answer, distillation. Next, during Lessine test, nitrogen and sulfur present in an organic compound changes to, so nitrogen changes to NaCN, right, and sulfur changes to Na2S, so option number A. Next, in Zeldal method, ammonia from 8 gram of food neutralizes 60 centimeter cube of 0.1 and acid. The percentage of nitrogen. So if you remember, percentage of nitrogen formula is 1.4, right, into N into V divided by mass of the organic compound. So I can substitute the values, 1.4 into, what is N here, 0.1, what is V here, 60, divided by mass is 8, right. So I can write it like this, 14 by 10, 1 by 10, 60 by 8. Okay, so this can be cancelled. You will get now 2 4s are 8, 2 3s are 6, 2 2s are 4 and 2 7s are 14. So 7 3s are 21 by 2. Okay, so 21 by 2 I can take like this, 10.5. Okay, again divided by 10 is there, so 1.05, option number A here. Next, okay, this is another question. Okay, in Zeldal method, ammonia, 5 gram of ammonia food neutralizes 30 centimeter cube of 0.1 N acid. The percentage of nitrogen. So very similar to the previous question. Okay, we can just directly do it. So 1.4 into 0.1 into 30 divided by 5 grams, right? So I'll do like this, 14 by 10 into 1 by 10 into 30 divided by 5. So I'll get this one, 5 1s are 5 2s are 10. So I will get, sorry, 5 2s are 10, 2.8, 5 8s are 40, 5, yeah, 2.8. So 3 8s are 24, 8.4. So I'll get 0.84. Okay, option number A here. Next, an organic compound weighing 0.15 gram of a 0.15 gram gave on carrier's estimation 0.12 gram of AgBr. The percentage of bromine in the compound will be close to. Okay, so now if you know the mass of AgBr is 188, right? So in 188 gram you have 80 gram of bromine, right? Now in 1 gram how much it will be? 80 by 188, right? Then in how much AgBr was produced? 0.12, right? So it will be 80 by 188 into 0.12. Okay, this much gram of bromine will be produced. Next, percentage of bromine will be, you have 80 divided by 188 into 0.12 divided by 0.15, okay, into 100. Now if I solve this, we will be getting 34.1%. Okay, Next, nitrogen detection in an organic compound is carried out by Lassine test. The blue color formed corresponds to which of the following? So if you remember, the Prussian blue is formed while you treat the nitrogen with Fe2 plus and then Fe3 plus. So that is because of this complex Fe4 FeCN6 whole 3. Okay. Next, an organic compound which produces a bluish green flame when heated on copper wire is your chlorobenzene. Okay, so chlorobenzene, you will get this color. Next, in Lassine test for nitrogen in an organic compound, the blue coloration is due to the formation of again ferriferrocyanate, or the formula you have remembered here, Fe4 FeCN6 whole 3. Okay, so this one you should be very clear with the option ferriferrocyanate. Okay. Next, identify the electrophile. So you can see here AlCl3. AlCl3 is what? Lewis acid, electron deficient. So this is an electrophile here. Okay. So yes students, that's all in this class, and I hope you would have enjoyed the class, you would have solved all the questions. If you have any doubt, please put down in the comment section. I'll definitely address it. Okay, thank you for watching and see you soon in the next class.